welcome back to the next part in the B200 clock series video. As you can see, we finally have the clock constructed in its full form. In this video we'll be going over the hardware components on the top and the bottom, some of the hardware issues that we encountered during its assembly construction, as well as testing. Include a montage of me putting the central pieces together with the assembly disc, rods and the acrylic tube. So let's have a run through the hardware. Starting at the bottom, we have the bottom cover plate with its 4 mounting feet, as well as the heatsink that makes direct contact with the stepper motor in the back, with additional copper strip to aid in the heat dissipation. Take it off, simply remove all 4 of the rubber feet. You'll see on the inside we have additional copper tape as well as some foam just to aid in contact with between the stepper motor and the heatsink. In the bottom enclosure we have all of the power electronics. You'll see there's a cable harness coming through from the top with some of the wires for the LED ring, power delivery and serial communication, so that's the wires coming through here. Stepper motor mounted here centrally, underneath which sits the LED ring as well as the distance sensor, backup LiPo battery, and that is run through the relay over here. So either we get power from an external 12 volt source, or we can press the power button to run it off the LiPo battery directly. The left hand side we have the on and off switch that couples to the 12 volt regulator, the brightness potentiometer to set the brightness of the LEDs, the input 12 volt connections. You'll see these are connected in parallel to the port on that side. There's one and there's two just for redundancy and as a 12 volt pass through in future. And then the top electronics board is handles all of the power conversion as explained in one of the previous videos. We've got our Arduino Nano controlling the stepper motor, but also relaying a lot of the information over the serial communication line. You'll see in the bottom there is a small temperature probe that's glued on directly onto the stepper body, as well as the stepper wires coming out over on this end. I did try to shield some of the wires. There's still some pertinent interference issues, especially when the stepper motor is running quite quickly. I'm guessing it's a proximity between the serial connection over here, the motor, as well as the power electronics that drives the stepper motor over on that side. This can be mitigated in software just to pick up issues if there is an incomplete message, so it's a bit of a hit and miss, but overall it works quite well. Same goes with measuring the LiPo battery voltage. We have got a resistor divider network, but again there's some noise when the motor is running, so in general expect some interference when you're placing low level logic and analog signals. Serial comms close to these magnetic fields generated by the stepper motor. So that's it for the bottom enclosure. As I mentioned, some of the wires running to the top and from the top down to the bottom, primarily power, serial comms and then the LED control wires. For the body of the clock we have the disc assembly mounted over there, and the brass or the bronze nut you can see there as well. You'll see the magnetic clutch. This has been replaced with traditional linear bearings, each that has a magnet attached to it, and this is allowed to run freely along the axis. Here at the bottom we have these 4 stoppers just to prevent the magnetic clutches from falling down to the bottom and not being able to re-engage with the disc assembly. It's working very well. We'll see that in the calibration procedure, and then the needle is attached there as well. Overall, minimal amount of dust or scratch marks on that disc assembly, so really looking good. Overall the unit is nice and sturdy, and there at the top you can again see the artwork for the constellations on the gold foil. Moving down to the bottom we have our lid over here. The sensor has already been attached, the gesture sensor to control the unit, with a small quick connector that connects to the top body of the top enclosure. Looking in a bit more detail, we've got the controller board over here, I2C connector cable for our gesture sensor, all of the different sensors. These are the spark fun sensors for temperature, RTC, EEPROM, temperature and air pressure, and we've got this also connected to the I2C screen over here, and the brightness of which is controlled separately using the Arduino with pulse width modulation for the display brightness. Then we've got the lead screw coming through, so space available to add lubricant in future if it dries up a little bit. Otherwise, just a lot of tape and a bit of a glue gun to keep everything in place. Here's the cable harness coming through from the bottom, and then the temperature sensor is positioned underneath this cotton that acts as an insulator. You'll note that at the bottom of the top enclosure, it's a small little hole. That's a vent hole that's directly coupled to the temperature sensor to better sense changes in the environmental temperature. We've got some LED indicators here. Just use the permanent marker to color them in to prevent light, especially at night. That can be a bit obtrusive for the overall effect, so just make sure to blank that out. So overall, very happy with the final construction. Let's move on to the calibration step once the unit powers up. Moving on to the calibration procedure. Currently the clock is not currently powered on. We'll enable the power. You will hear the servo motor clicking into action. So currently you'll see the disk assembly moving down with the needle also moving, and that's because the sensor down there in the bottom has yet to be continuously activated when this disk assembly moves around about 50 millimeters from the bottom. So that's the first part of the calibration. Get the disk approximately 50 millimeters away from that position. So that point has just been reached, and now slowly the disk will move back up just that it is out of reach. Then we know it's around about 55 millimeters away from that sensor, and with the needle we can differentiate where the needle is and where the disk assembly is. So knowing that 55 mils, we can drop down by a set number of turns. I think it's 9 turns in this case, up until the disk assembly reaches the needle indicator. So there you'll see the clutch is starting to slip, but the linear bearings are free to move about. The final couple of rotations, then we know we've reached exactly the point that we need, and now the entire system is calibrated. So we know where the zero position is, we know relative where the needle is, and at this point in time it's currently set to century mode, and this will move around about a quarter up since it's the year 2024. So it'll do this slowly up until it reaches the position, and then move from there where the specific mode is. I can turn the LEDs off just by turning the potentiometer here to turn off the brightness. If it's below 5, the LEDs should turn off. Turn that all the way, and if we want to turn on the LEDs and increase the brightness, we can also do that, so it'll sequentially move up in brightness. So I mentioned before, at this point when the stepper motor moves, and I've noticed when the disk bladder is at a low position, there's quite a bit of interference, and then the position received by the stepper motor in the bottom will either be 0 or the position that it needs to reach. So you'll see the needle is slowing down quite a bit because it's receiving a few zeros and it wants to move to 0, but then getting another reading for about 150,000 steps where it should be. This does stabilize after a minute or two, so it's just during these initial power up stages where the noise is a bit of a problem, but the software does take care of that for the most part. Looking at the display, we can currently see the mode at which it's set, and if we then activate the gesture sensor, we can see the number of power cycles, 75, the Wi-Fi connectivity, it's at 23,000 out of 640,000 steps, and we can continue going through the setting. Calibration is completed. You'll see that the disk currently is set in the year mode, so approximately 1/4 of the way up towards the top, and on the ticket it also says 160,294, so just more than a quarter of the year, which is correct. Today is April 1st, so 3 months have passed a quarter of the year, so that is definitely correct, and you won't really see it moving at all in real time. Once everything's up and running, even with the LEDs on, you can remove the power connectivity, and now the clock is significantly running solely on battery. and we can have a look at what that voltage is. 3.42. It was on 3.9 while it was charging, so it can run approximately an hour to 2 hours on the battery, but it serves more as a general backup. And that's the electronics and the assembly of the clock alongside the calibration portion of it. So thanks for watching. The final part of the video will be coming up that covers the software and the functionality of the clock, and then lastly perhaps a cool time lapse during the course of the day to see the clock in action. Thanks for watching. Don't forget to leave a like on the video, leave your questions in the description, and until next time, thanks for watching.